Okay, so 9.5 is all about the effects of changing dimensions and proportionality. So you are going to describe the effect of each change on the area of the given figure. So this says for A that the height of the triangle is multiplied by 6. Okay, so one way that you can do this is you can find the area of the original. Okay, so we're going to find the area of the original triangle. So Avery, what's the formula to find the area of a triangle? Good, 1/2 times base times height. Okay, so then Xavier, for this one, I'm going to do 1/2 multiplied by what? For
times 6 or
for the original. So what you see here.
5 times 12.
Okay, yep. So you're going to do 12 and 5. So what is 12 times 5? 60. So half of that is 30. Okay, so this is going to be 30 inches squared. Okay, so that's the area of the original. Now what we can do is we can find the area of the triangle with the height multiplied by 6. Okay, so again, it's still area equals 1/2 times base times height, but this time to find the new height, okay, if the original height is 5, what's our new height going to be? It's going to be 30, right? Because that's your 6 times 5. Okay, so then your area is 1/2. Now the base is going to stay the same. Okay, the only thing that happened is our height changed. Okay, now what's 12 times 3? Well, 12 times 3 is 36, right? And then, yep, it'll be 360 when you put the 0 on it. What's half of 360? 180. Okay, so now what we're going to do is we are going to compare those. So the original was 30, the new was 180. Right? How much bigger is the new one than the original?
6 times.
How many times?
6 times.
6 times, right? So what's one way that you could figure that out?
180
Okay, yeah, so you could think of it as 30 times 6, right, is 180. You could also think of it as 180 divided by 30 is 6. Okay, so notice that 6 times 30 is going to equal 180. All right, so then when you're describing the effect, you're going to be writing a sentence on what is happening. Okay, so if the height is multiplied by 6, what happened to the area? The area is multiplied by 6. Okay, good. Now let's look at part B. So it says the diagonal SU of the kite with the given vertices, so R22, S40, T2, -2, and U, -50, is multiplied by 1/3. Okay, so again, let's find the area of the original. So to find the area of a kite, Riley, do you remember how we can do that? Good. Okay, so the area of the original is going to be 1/2 times diagonal 1 times diagonal 2. Okay, so let's find what those diagonals are. Now this is actually pretty nice to calculate. what your D1 and D2 are because you can just count your units. Okay, so Tanner, from R to T, how many units are there? 4, right? 1, 2, 3, 4. And it doesn't matter if you call that your D1 or your D2. Okay, and then we're going to find D2 here. So I'll give you guys a second to count those if you haven't already. Okay, and Sam, what's going to be your length for D sub 2? So that was this one, right? What about this diagonal? Yep, it's 9. Okay, so then I'm going to do the area equals 1/2 times 4 times 9. And really, I would just do half of 4 is what? 2. 2 times 9 is 18. So this is 18 units squared. Okay, and then I'm going to do area of okay, and now what I'm going to do is find the area of the kite where the diagonal SU is multiplied by 1/3. Because it tells you the diagonal SU is multiplied by 1/3. Okay, so SU was how many units? Okay, so if I multiply that by 1/3, what am I going to get? 3. Okay, so this is my new diagonal. Alright, so your D1 is still going to be 4, but now your D2 is going to be 3. Okay, so to find the area, I'm going to do 1/2 times 4 times 3. Half of 4 is 2. 2 times 3, 6. So this is going to be 6 units squared. Okay, so I'm comparing 18 to 6. What happened from 18 to 6? Got multiplied by 1/3, right? Okay, so notice 18 times 1/3 is equal to 6. Okay, so if SU is multiplied by 1/3, the area is also multiplied by 1/3. Okay, now with both of these, we notice that the same factor happens. If the height was multiplied by 6, then the area was multiplied by 6. If SU is multiplied by 1/3, then the area is multiplied by 1/3. But we're going to see as we continue that that's not always going to be the case. Okay, so we're going to go to page 2. Okay, so it says, describe the effect of each change on the perimeter or circumference and the area of the given figures. Okay, so we're going to describe the effect of each change on the perimeter or circumference and the area. Okay, so there's 2 different things that we're going to be comparing here. Okay, so the base and height of a rectangle with base of 4 feet and height 5 feet are both doubled. So first let's do the original. Okay, and Logan, how do we find the area of a rectangle? Okay, so for this one, what is our area going to be? And that's going to give you 20. now we also have to find the perimeter. Okay, so here's our area. And if you need to, you can also draw a picture, right? This is obviously not to scale. Okay, so if you had a base of 4 feet and the height of 5 feet, this is 4, 4, this will be 5 and 5. Okay, there's two ways that you could do it. The equation is 2 times the length plus 2 times the width, or you could just add all those together. Okay, so this would be 2 times 4 plus 2 times 5. Okay, so 8 plus 10, which is going to give you 18 feet. And then that's not squared. So your perimeter is 18 feet. Alright, now let's do the new rectangle. Okay, so the new rectangle is where both the base and the height are doubled. Okay, so Jared, what's my new base going to be? Yes, good. Okay, so you started with 4 feet, and then you're going to multiply that by 2. So, yep, your new base is going to be 8 feet. Jacqueline, what about your new height? 10. So 5 times 2 is going to give you 10 feet. Okay, so then, Aiden, what's my new area going to be? 80. Okay, so base times height, which would be 8 times 10, which is going to be 80 feet. I'm just going to circle that. Okay, and then the perimeter, again, it's 2 times the length plus 2 times the width. Okay, so 2 times 8 plus 2 times 10, which is going to be what? 36. Oh, sorry, this one's squared for your area. This one is not. Okay, so now what we're going to do is we're going to compare the area to the area, and then we're going to compare the perimeter to the perimeter. So compare. So the area went from 20 feet squared to 80 feet squared. Okay, so what happened? How much larger is it? 4 times, right? Okay, if we look at the perimeter, I'll call this area 1, area 2. Perimeter 1 was 18. Perimeter 2 is 36. What happened from 1 to 2? It doubled. Okay, now the order that you do this in matters, right? Because if my first area was 80, I wouldn't say that it quadrupled in size, right? Yeah, it would be a fraction of the size. I wouldn't say that this doubled, I'd say that it was in half. So it does matter what order that you're looking at those in. Okay, so describe the effect. So the perimeter doubled. And the area became 4 times larger. So the perimeter doubled and the area became 4 times larger when both the base and height were doubled. Okay, now when we go over more of these, you're going to notice a pattern. But see how this doubled and this was 4 times? Okay, if this is 2 times and this is 4 times, 2 squared is 4. Okay, that's going to be a relationship that you're going to see as we continue on. Okay, so for B, the radius of circle J is multiplied by 1/5. Okay, so we're going to do the original first. And Maddie H., what's going to be the area of a circle. Yep. Okay, and Caitlin, what's our radius for this? Good. So our area is going to be pi 10 squared. And we're just going to leave this in terms of pi. So this is going to be 100 pi centimeters squared. And then the perimeter of a circle is called the circumference. Okay, so we're going to find the circumference of the circle. Okay, and Luke, what's the equation for that? Yep, so 2 pi r, 2r times pi is fine. Okay, and then we're going to use 2 pi times 10. And again, we're going to leave this in terms of pi, so 20 pi centimeters. Okay, so this is our original circumference and our original area. Okay, now it says to multiply the radius by 1/5. Okay, so if our radius is 10, okay, if I do 10 times 1/5, it's just like I'm dividing. So, Baron, what's my new radius going to be? 2. Okay, so for my new circle, with 1/5 of the radius, I'm going to do area equals pi and then 2 squared. So 2 squared will be 4, so it'll be 4 pi centimeters squared. And then for the circumference, it's going to be 2 pi times r, so 2 pi times 2, because that's our new r value. Okay, and then Sierra, what's that going to be?
4 pi.
Yep, so that's going to be 4 pi, and that'll just be in centimeters. Okay, so now we're going to compare these. Alright, so then your first area was 100 pi. Your second area was 4 pi. Your first circumference was 20 pi. Your second circumference was 4 pi. Okay, it's probably simpler to look at the circumferences, right? If you had 20 pi to 4 pi, what happened? It was divided by 5 or multiplied by 1/5, right? What about from 100 pi to 4 pi? Divided by 25. Okay, so really what you're looking at is, in this case, you're dividing, right? And you can see that's 25. 20 pi over 4 pi, you can see that's going to be 5. So it is going to be changed by 1/5. Okay, so the circumference is multiplied by 1/5. While the area is multiplied by what? By 1/25. Or you can think of it as 1/5 squared. Okay, so if you were to square 1/5, you'd get 1/25. Okay, so again, remember here how I said 2 squared is going to be 4? 1/5 squared is 1/25. which makes sense because the area is always going to be in units squared. Okay, and the perimeter would just be in whatever your units were. All right, and then on the last page, we have a circle that has a circumference of 32 pi inches. If the area is multiplied by 4, what happens to the radius? I'm going to highlight that question. What happens to the radius? Okay, so we have to describe what's going to happen to our radius here. So, if the circumference is 32 pi inches, I can use that to find what my radius is going to be. Okay, so use the circumference to find the radius. So if circumference equals 2 pi r, and I know that it's 32 pi, I can solve this for r. Okay, so Ethan, if I want to solve this for r, what am I going to do to both sides? Okay, so you can divide by pi. You could actually divide by what with it, too? I could divide by 2 pi, right? You could do it in one step or you could do it in two. Now, when you divide by 2 pi, these divide to make what number? 1. So that's why we're left with just r. Pi over pi, that's going to divide to make 1 as well. And what's 32 divided by 2? 16. So that means your radius is 16 inches. Okay, so now that we've done that, now we can find the original area. And Brandon, what formula am I going to use to find the original area? Yes. Okay, and now that I have my r, I can plug in 16. Do you guys know what 16 squared is going to be? Yes, so this will be 256 pi inches squared. Okay, and again, we're leaving that in terms of pi. Okay, so now we can find what happens when the area is multiplied by 4. Okay, so if I multiply the area by 4, I'm just going to take 4 and multiply it by 256, and I'm going to keep that in terms of pi. Okay, so 256 times 4 is going to be what? 1,024. And again, that will be in terms of pi. Okay, so this is going to be inches squared. And then you have to figure out what happens to the radius. So then what we're going to do is we're going to use the new area to find the new radius. So what we did is we multiplied the area by 4, right? So now we can observe what's happening to the radius. Okay, so the area equals pi r squared, and we just found that our area was 1,024 pi. And then we're going to solve this for r. Okay, so Matthew, what are we going to start by doing?
We're going to divide by pi.
Good. Okay, Brianna, after we divide by pi, we're left with r squared equals 1,024. What can I do to just get r by itself? Good. Now when you take the square root, you normally have plus or minus. Since we're dealing with real shapes, it will just be positive. Okay, and let's take the square root. Is it a perfect square?
Yep. Yeah.
What is it? 32. Okay, so then my radius is 32 inches. All right, so now I can compare. Okay, so my first radius was 16 inches. My second radius was 32 inches. What happened? It doubled. Okay, so what we would say is if the area is multiplied by 4, then the radius doubles. So again, that's 4 to 2. So the square root of 4 is 2. That's going to be the pattern. Okay, so you're going to notice when you're dealing with area, you're going to have a lot of things squared. Okay, so like I said, you won't have any homework on this tonight. We're going to spend the rest of the time reviewing for our quiz. And then tomorrow, I'm going to give you your homework, which will be a 9.5 worksheet. Okay, but I don't want you to worry about that tonight because I want you to study. Okay? All right, so what I need you to do is clear off your desk except for a pencil and a sheet of paper and a calculator.